Welcome to this explainer. Today, we're going to unpack how a major architectural shift in AI is about to drastically, and I mean drastically, collapse your creative production time. Look, if you work in visual design, marketing, or content creation, you already know that the current state of AI image generation can be a bit of a double-edged sword, right? It's amazing, but it can also be incredibly frustrating. Well, today, we are looking at a breakthrough that changes that equation entirely.
Let's just dive right into a pain point I know we can all relate to. We all know the absolutely exhausting cycle of endlessly generating and tweaking prompts just to get one single usable image. You type a prompt, you get a beautiful image back, but the text on the sign is spelled wrong, or it gave your subject 6 fingers, or the object count is just totally off. So what do? You re-roll, and re-roll, and re-roll. But what if you literally didn't have to do that anymore?
To see how we fix this, we'll start by looking at the generate and curate bottleneck. Then we'll peek under the hood of Google's Muse architecture, check out Markov Gen's insane need for speed, see how this revolutionizes your daily workflow, and finally, wrap up with meta, privacy, and open source.
All right, part 1, the generate and curate bottleneck. Let's establish our current baseline and figure out exactly why designers everywhere are suffering from serious AI fatigue.
There is a massive gap right now between advertised AI capabilities and your actual day-to-day workflow. Why? Because traditional generators are fundamentally, architecturally incapable of reliably translating specific instructions into exact outputs on the first try. They're great at the overall vibe, but terrible at the specifics. This forces you into a really tedious generate, curate, and fix workflow. You might ask for a specific building style or precise typography, and you get an approximation. Then you're forced to take that approximation into Photoshop and spend 20 minutes manually compositing the details the AI missed. It's a huge bottleneck.
Moving on to part 2, inside Google's Muse architecture. This is where things get really interesting, because we're looking at the mechanical solution to this exact problem. This isn't just an aesthetic upgrade, it's a structural rebuild of how an AI renders an image from the ground up. While traditional models, like your standard Stable Diffusion or DALL-E, use a slow, iterative pixel space diffusion process, which basically removes noise step by step to reveal an image, Muse does something entirely different. It uses masked generative transformers. This means it predicts discrete image tokens in parallel, so instead of slowly fading an image into existence, it decodes everything simultaneously. Boom! It's vastly, vastly faster. At the very heart of this is a technique called masked image modeling. By utilizing a frozen, pre-trained T5 language model, Muse actually achieves incredibly fine-grained language understanding. For a designer, this is basically the holy grail. It translates to accurate spatial relationships. You want a cat under the table, it puts the cat under the table. It gets exact object counts right and offers precise text rendering. It completely eliminates the need for manual compositing after the fact.
Which brings us to part 3, Markov Gen's need for speed. Because Muse was already fast and accurate, but researchers found a brilliant way to turbocharge it even further.
Just take a look at these numbers to put this into perspective. At just 1.3 seconds to render a 512 by 512 image, Muse is already blowing top diffusion models out of the water. That's more than twice as fast as Stable Diffusion 1.4, and get this, an astonishing 10 times faster than autoregressive models like Party 3B. But you know how it is with professional workflows. Even that wasn't quite fast enough for real-time iterative design.
To push the speed limit even further, researchers introduced a system called Markov Gen. Basically, Markov Gen applies a lightweight Markov random field model, or MRF, which acts like a fast-forward button for the final generation steps of the Muse model. By explicitly modeling how image tokens relate to each other spatially, it cuts down the massive computing time required for those final, really tedious refining steps. The result? A massive 1.5x speedup over the base Muse model. And the best part? This speed does not sacrifice quality. Actually, scratch that, it improves it. By comparing the progression of this red sports car with the early exit Muse steps on the top and the MRF applied steps on the bottom, you can see how the MRF inference instantly removes those undesirable artifacts and weird texture inconsistencies that usually plague the early steps of generation. You get a completely production-ready asset in a fraction of the time. Let's dive into part 4, revolutionizing the designer workflow. Let's see how all this highly technical architecture builds into an absolute game changer for your daily grind. The time from, I need an image for this post to, here's the finished image, drops from 30 minutes of generate, curate, fix to 3 minutes. I mean, wow, this quote perfectly captures the death of the generate and curate workflow.
We're officially moving into the era of agentic AI. This is an AI that doesn't just blindly paint pixels. It reasons, it searches, and it evaluates prompts before generating. Think about it. If you're on a marketing team submitting a creative brief, you absolutely do not want an approximation. You want exact execution.
And the data backs this up. In human evaluations for text alignment, people chose Muse over Stable Diffusion over 70% of the time. That proves you get exactly what you ask for. If you need a promo image with a t-shirt that says Carpe Diem, the AI actually renders Carpe Diem perfectly. You don't need to open Photoshop to fix typos or weird melted alien letters anymore. The economic case for bringing this AI into production workflows just became totally undeniable.
This reduces your production time so drastically because the AI is essentially acting as your personal design assistant. It goes out and fetches real-world facts to make sure backgrounds match actual geographic locations. It can even code functional elements. Seriously, if you ask for a QR code in an infographic, it actually computes a real scannable QR code instead of just drawing black and white squares that look like one. It shrinks that soul-crushing 30-minute chore of generating, curating, and fixing into a breezy 3-minute process of generate and approve. Finally, Part 5, Meta, Privacy, and Open Source. Let's take a look at how this incredibly powerful tech is rolling out into the real world right now, and what that means for both your privacy and your custom toolkits. So Meta is currently integrating its own highly advanced version of Muse right into its suite of apps. Their model follows instructions faithfully and edits with absolute precision. But what's really unique here is that it allows users to tag public profiles. That way, the AI can draw media directly from those accounts to provide accurate, real-world social context for the images it generates.
Now, as a designer or a creator, your assets are your livelihood, right? So if you prefer to keep your personal creative assets totally out of this context-scraping system, you can easily opt out in your Instagram settings. It's super simple. Just jump into your profile, tap the 3 lines, navigate to Sharing and Reuse, and toggle off sharing your posts and reels for Meta's AI features. This ensures your portfolio remains completely yours.
On the other end of the spectrum, for developers and studios who want a really hands-on, customizable approach, Hugging Face has released aMUSEd. This is an open-source reproduction of the Muse architecture using just 800 million parameters. Why is that a big deal for you? Because it's lightweight enough to run super efficiently. That means your studio can fine-tune this model on your own proprietary, custom datasets and brand guidelines, and you don't even need a massive supercomputer to do it. So, the absolutely crucial takeaway here is this. We've seen how masked image modeling and systems like Markov Gen bridge the gap between your initial inspiration and that final production-ready image. Look at this beautifully rendered floating house. It's exactly what was prompted, generated rapidly, and there was zero need for endless human revisions. Accuracy is the bridge that turns AI from a fun little toy into a heavy-hitting core production tool. I'm going to leave you with this thought to wrap up our explainer today. If the tedious, soul-sucking busy work of curating 20 bad drafts and manually fixing tiny errors in Photoshop completely disappears, where will your newly freed up time and creativity take you next? Thank you so much for joining me for this breakdown, and I'll catch you in the next one.